Hi, this is Dr. Lisa Fry, and I am going to be talking to you today about subnet addresses and how to determine your subnet address. First, why do we want a subnet? The main reason to subnet is to organize your network into efficient and an effective manner. More specifically, we want to improve network performance. And we can do this by limiting the broadcast domain. So when you create subnets, your broadcast packets will remain on the subnet and not propagate to the entire network. So you're limiting traffic and congestion on the other parts of the network. Security. You can combine the subnets with other measures such as access control lists or QoS to limit traffic and to specific subnets and increase your security. And management for easier administration and troubleshooting. By organizing your network into subnets or smaller parts, it's easier to manage and organize and troubleshoot. Talk a little bit about what is CIDR or classless internet domain routing. Your typical addressing is classful. So you have class A, class B, class C. But with classless addresses, you aren't limited to those classes. Really, the CIDR is a alternate representation for the subnet mask, also known as slash notation. So instead of having to write out a full 32-bit subnet mask, you're going to do /x, where x represents the number of bits in the network and subnet portion. Or if you have your subnet mask already, it's the number of ones in your subnet mask. CIDR also requires updated routing algorithms, routing protocols to handle routing with classless addresses. But we want to focus today on creating those subnet masks or subnet addresses. So my guidelines for creating these subnet addresses are these simple rules. For each subnet X, what you want to do is write X in binary using the total subnet bits. So if you're working on subnet 1, you want to write the number 1 in binary using the number of bits you've identified for the subnet. And then for the host bits, when you're working with the network address, your host bits will be all 0. So if we're working with subnet 1, and let's say that we've identified 5 bits for subnets, what we're going to do is write the number 1 using 5 bits in binary. So we will have 0, 0, 0, 0, 1. Then all of the host bits will be 0. So if we're working with a class B address, 16 bits are assigned to the network portion. So that means we have 16 bits to work with for subnet and host. So we're going to do 5 bits for subnet, which leaves us 11 bits for host. So I'm going to write subnet 1, 1 in binary, 0, 0, 0, 0, 1. And then the 11 host bits will all be 0. Then what you do is you take those 16 bits and convert them to octets. So we're going to have our 0, 0, 0, 0, 1, and then 3 zeros, and then the remaining 8 host bits will be our last octet, and then you convert that to decimal. So write the subnet number, if you're subnet 1, or if you're subnet 7, you're going to write the number 7 in binary using your total subnet bits, or in this case 5 subnet bits. We'll write the number 7 in binary using those 5 bits. Your host bits are all zeros. For the broadcast address, you do the same thing, except instead of your host bits being all 0, your host bits are all 1. And then you convert that to octets and decimal. And then the usable addresses within the range for assigning IP addresses to specific hosts are that range between the network address and the broadcast address. And then a rule of thumb or sort of a de facto standard is that you will use the first address in your host range for the first router interface, and you'll use the second address in the host range for your second router interface. So let's take a look at some examples. The first example is you are a network manager and you've decided you want to subnet your network. Your organization was given a Class B network address, which is 142.50.0.0. Class B, so it means the 142.50, those 2 octets, those first 16 bits, they're assigned to us, they're set, we can't change them. What we do have is the last 2 octets or 16 bits to work with to break up our subnets and hosts. You decided that with your network organization, your physical network, you decided to create 40 subnets. So we want to identify the network address, broadcast address, and range of available host addresses for all of the subnets, but we'll work with the first subnet. So again, we have the 142.50. So my first two octets, and just for abbreviating this discussion, I'm just going to leave those first two octets, since they're set, I'm going to leave those in decimal. I could convert those to binary and then convert them back to decimal. Since I need 40 subnets, what I need to do is find the power of 2 that will be higher than 40. And then that power of 2, that 2 to the n, that n will be the number of bits for subnets. So because I want to use 40 subnets, I'm going to use 6 bits for subnets, because 6 bits will give me 2 to the 6, which will give me 64. Now, typically, we will do, and I do this, is you will subtract 2, because we don't want to use an all 0 subnet or an all 1 subnet. All 0 can confuse you. If I have a 0 subnet, my subnet address is going to be 142.50.0.0. And then I will get confused. Do I want subnet 1 for 142.50.0.0, or am I referring to the entire network of 142.50.0.0? And the same if we use all 1s. And there's a nice paper about the 0 subnet and all 1 subnet that you can read more about this. So I have 62 subnets. I'm using 6 bits. I have 32 bits in my address. 16 bits are already assigned to the network portion, so that means I have 16 bits to work with. I'm using 6 bits for subnets. So 16 minus those 6 bits gives me 10 bits for my host addresses. And then again, we do 10 to the 2 to the 10 in this case. And for hosts and networks, or for hosts, we do want to subtract the -2. Not everybody will subtract the -2 for the number of subnets, but we want to always subtract it for hosts, because you can't have an all 0, a host with host bits of all 0, because that refers to the network address. And you can't have a host bit of all 1s, because that refers to the broadcast address. So in this case, we're going to do 2 to the 10 minus 2 to get the number of hosts that we can have on a subnet, on each subnet. So what we're going to do is, now we're going to convert those to first subnet. So let's look for subnet number 1. So what I'm going to do is, I have my 142.50. Again, I'm not going to touch those 2 octets. I have 6 bits for subnets. 1, 2, 3, 4, 5, 6. And that leaves my 10 for host. So now if you remember, what I'm going to do is I'm going to write, using those 6 bits, I'm going to write number 1 using 6 bits. 1. And then for the network address, my host bits are all 0. Then step 2 is I convert these to octets. So I have 6 bits here. So I need to take 2 of the bits from the other one, the 10 bits for host, and that leaves me with 2 in that octet. And then I have 2 in this octet. And then I convert this to decimal. So it's 142.50.4.0. And that's my network address. Now remember, we want to do the slash notation. So what I want to figure out is how many bits are in the host, how many bits are not in the host, how many bits are in the network and subnet. So I take my 16 bits for the network, my 6 bits for the subnet, and I end up with a /22. So the network address for the first subnet is 142.50.4.0. Now to find the broadcast address for subnet 1, I do the same thing, except now what I'm going to do is I'm going to make those host bits right here, instead of my 10 zeros, I'm going to do 10 ones. So I'm going to have 142.50, 1, 2, 3, 4, 5, 1, our number 1 in 6 bits, and then 10 ones. I convert that to octets. and then I convert to decimal, which if we do this calculation will be 252.255. I'm sorry, 142.50.7.255/22 is my broadcast address. If we want to write the subnet mask out, we just use the /22. We have the remember for subnet. If it's part of the network or subnet, it's a 1. If it's part of the host, it's a 0. So I have 16 bits for the network portion. I have 6 bits for the subnet, and then the last 10 are for the host. So I have 255.255.252.0. And then my IP address range for hosts on the network or for devices on the network would be 142.50.4.1, right, the one right after the network address, through 142.50.7.254, the one right after or right before the broadcast address. Okay, so we take our subnet number and write it in binary using the number of bits we've identified for subnets. Make the host bit 0, convert to octet, convert to decimal, add the slash notation. For the broadcast address, we make our host bits all 1s, and then the range is everything in between. And using the de facto standard for routers, our first router interface would be 142.50.4.1/22. The second one would be 142.50.4.2, etc. Okay, let's look at another example. And in this case, what we're going to do, now we're a network manager in an ISP, and we have a Class A network, 98.0.0.0. So what I have now is I have 4 octets. The first octet is for the Class A, so that leaves me 3 octets or 24 bits to work with. I've decided that I want to set up my address to start taking on clients. I want to start setting up subnets, and I've decided to allow each client a maximum of 30. I'm not worried about growth, which if it were my own network, I would want to worry about future growth. So I want to find out the network address, broadcast address, and range of available addresses for the first subnet. So now again, if I want 30 hosts, I need to find that 2 to the power. So what 2 to the power is going to give me more than 30? And don't forget, you have to subtract 2. And in this case, it's 5 bits because 2 to the 5 minus 2 will give me that 30. So for subnets, I start with my 32, I subtract my 8 for my Class A, and I subtract the 5 that I'm going to work with for hosts. So I end up with 21 bits. Now, if I can do subtraction, 24, I end up with 19 bits for subnets. This just shows you have to double check your math work. So I have 19 bits for subnets. So when I do total subnets, that's going to be 2 to the 19. And again, I'm going to subtract the minus 2 because I don't want to use the 0 subnet or the all 1 subnet. So that'll give me the total number of subnets. So now for subnet number 1, I want to take 1. Now I have 98 here, and I have 19 subnet bits. And 5 host bits. So now what I want to do is I want to write 1 using 19 bits. So I'm going to put 18 zeros and my 1, and my host bits are all 5s, all zeros. my 5 host bits are all zeros. So now I do the 98, and I convert these to octets. There's 8. There's 8 more, or 16. So that leaves me 3, and then my 5 host bits. And then when I convert this to decimal, I get 98.0.0.32. And for my slash notation, 0.32. And for my slash notation, I'm using 8 for the network and 19, so I end up with /27. That's my network address. For the broadcast address, again, we want to take the same thing right here. My 1 in 19 bits, except my host bits are all 1s. I convert to octet. And then I convert to binary. And I use the /27. And then my range of IP addresses for devices on the subnet is my network address, the next one, and one less than the broadcast address. So I can use 98.0.0.33 through 98.0.0.62 /27. And that's my usable. So my first router interface will be 98.0.0.33. The second one will be 98.0.0.34. So those are 2 examples. Again, the guidelines, what you want to do is whatever the subnet number, if it's 10 or 30 or 3, you want to take that number and write it in binary using however many bits you're using for subnets. You want to then convert that binary to your octets, and then convert the binary to decimal, and that will give you the network portion if you have your host bits all 0, and it will give you the broadcast address if you have your host bits of all 1. So that's a short review on how to assign subnet addresses. Thank you for watching.